Alright, so part 3. So the last video here, hopefully these have been helpful. So we have this table up here. This table represents our f function. So first one just says f of -4. So -4 is my input. I'm looking for the corresponding output. So here's -4. The corresponding output is 8. So that wasn't so bad. Now, f inverse of -4. The key here is just figuring out what the heck does this mean. So this is a table for f. So f inverse of -4. This -4 is representing an output on my f table. So -4 as an output. That's right here. Corresponding input is 4. So f inverse of -4 is equal to 4. All right, f inverse of f of 6. So let's just break this into pieces. So first I'm going to find f of 6. So 6 is an input. So 6 has an output of 8. So now I'm really just trying to find f inverse of 8. All right, so what does this mean? 8 now represents an output on my f table. So where do I have an output of 8? I have one here, and one here. So that means I have two answers here. So f inverse of 8 is either 6, but it's also -4. So that means f inverse of f of 6 is equal to 6, and it's equal to -4. We have two solutions there. All right, and then the last one, f inverse of -4, f inverse of f inverse of -4. So let's find f inverse of -4 to start. So f inverse of -4 means -4 is an output on the f table, and then I need to find the corresponding input. Right here, that's 4. So now I'm looking for f inverse of 4. So now same strategy. I'm looking for an output of 4 on my f table. Uh-oh. There's no output of 4. So that just means no solution for this one. All right. So nice work on the table there. Now, part E says, is the above function invertible? How do you know? Well, what does it mean to be invertible? Invertible means if I switch the inputs and the outputs, then my new function is also a function. Well, would that work here? And the answer is no. And how do I know? I know because of these two 8s right here. Okay, so right here we found out f inverse of 8 is 6 or it's 4, which means when I switch the inputs and the outputs, 8 would become an input, but it would have two possible output values. So is this function invertible? No, it is not. How do I know? I'm just going to say C part C. So you guys can explain it however you want, but I just kind of gave you a brief explanation. If you switch the inputs and the outputs, then 8 would have two corresponding outputs when it becomes my inputs. All right, so number 7. First it says find an equation for f inverse. So remember my strategy is we start with our function y equals 2 over x plus 5. And to find the inverse, we switch the x and the y and solve for y. So x equals 2 over y plus 5. Sorry, a little sloppy there. All right, so how am I supposed to do this? Well, I guess I should multiply both sides by y plus 5 to get it out of the bottom. So let's start with that. So x times y plus 5 equals 2. All right, I'm going to come back up here. Now what? Well, remember, what is your goal? Your goal is to get x by itself. Okay, so we have a couple options algebraically. Algebraically, we could take this x and distribute it. But if my goal is just to get y by itself, let's just get rid of this x. How could I get rid of the x? Well, this is x times all of this. So to get rid of the x, I'm just going to divide. So if I divide both sides by x, I get y plus 5 equals 2 over x. And then to finish this up, I'll just subtract 5. So y equals 2 over x minus 5. And so that is my equation for f inverse. So f inverse of x equals 2 over x minus 5. Okay, so it says check the above answer by finding that f of -4 equals n, some number, and verifying that this is equal to f inverse of n equals -4. Okay, so those directions might be a little confusing, but basically what this is saying is plug in -4 into f and see what you get. And then whatever you get as that output, plug it into your new f inverse equation and make sure you get -4 back out. Okay, because remember, my definition says f of f inverse of x equals x. So in this problem, if we plug in -4 and we get some output, we should be able to take that output, plug it into f inverse, and get back -4. We start with -4 and with -4. So let's plug in -4 into my f function. So 2 over -4 plus 5 would be 1. 2 over 1 would be 2. Okay, so f of -4 equals 2. So according to what I know about inverse functions, if f of -4 is equal to 2, that means that f inverse of 2 should be equal to -4. Switch the inputs and the outputs. So let's check it. So I'm going to come to my f inverse equation, and I'm going to plug in 2 and see what happens. So f inverse of 2 is equal to 2 over 2 minus 5, which is equal to 1 minus 5, which is -4. Okay, so this means I'm good to go. But we just found out that if I plug in -4, I get 2 in my f equation. And if I plug in 2, I get -4 in my inverse equation. So that makes me happy. All right, and then last one for this problem, find the domain and range of f. All right, so what is my red flag on this equation? Because we can plug this in our calculator, but this is actually one where it's going to be easier if you just think about it. So domain, I see a fraction. That makes me nervous, because if the bottom of my fraction is equal to 0, then I get an undefined value. So the question I'm asking myself is, what number am I going to plug in for x that's going to give me 0 on the bottom? Okay, and the answer is -5. So my domain is going to be everything except -5. Now there's a couple ways you could write that. You could say -infinity all the way to -5, parentheses, because it's not included, union, take a break for a second, and then -5 for forever. So this is just a fancy way of saying go all the way from -infinity to infinity, but don't include -5. If you wanted to use your set notation, you could say set of all x values such that x does not equal -5, meaning everything is fine except -5. All right, now the range is a little bit tougher to see. So what could I do here? Let's just see what the graph looks like. Then we can come back and talk about it. So type in my equation. So 2 divided by, what was it, x plus 5. All right, and hit graph. All right, so first thing we can see is, looks like we have this vertical asymptote right here at -5, which lends itself to make me think that I did a nice job with my domain. Looks like all my x values are hit except at -5. But is it, I mean, just by looking at the graph, it's kind of hard to tell. Is it -5? Is it -4? Is it -4.5? So doing that algebraically, I think, is cleaner. Now, as far as my range is concerned, it's going up for forever, it's going down for forever, but it looks like there might be a horizontal asymptote right here at 0. So my first guess is everything except 0 is my range. Now, how could I check that? Well, a couple things we could do is we could look at the table. So if I pull up a table and I just start scrolling down, let me make these values bigger actually. So let me go to my table setup. Instead of it being 0.01, so this delta table, this means how much are my values going to go up by. I'm going to change this to 1, just so it's quicker to scroll through. Alright, so as I scroll through, as x is getting bigger and bigger, it looks like my values are getting closer and closer to 0, but it looks like we're also kind of flattening out. So this makes it look like 0 is not going to be included. Okay, how do I know for sure? How do I know it's not like 0.01? You know what I mean? So what can I do to test this? So for range, if I'm ever pretty sure about a value, think about what we're trying to do. We're trying to figure out if 0 is a possible output. All right, well, let's just plug it in as an output in my f equation and see what happens. So let's set the whole equation equals 0 and just test for it. So if I set the whole equation equal to 0, then let's solve for x. So how would you solve this equation? Well, you would multiply both sides by x plus 5. 0 times x plus 5 is 0. So you get 0 equals 2. Uh-oh. 0 does not equal 2. That's not true. So what does that mean just happened? Well, what that means is we just found out 0 is not a possible output value because we cannot find an input value that corresponds with it. So this right over here in green, this is proof that 0 is not in the range. Okay? Any other number you put over here, you would be able to solve for x. But 0, we get a non-real answer, so 0 is not in the range. So to write this, we can do similar to what we did above. We can say f of x is contained in negative infinity to 0, pause 0 to infinity, or you could say the set of all f of x values such that f of x does not equal 0. So either way is fine. Remember, I don't care how you write it. I just care that you can read both. All right, almost done. So we're going to use the graphs here to find some of these values. So the first one, f of g of negative 1. So g of negative 1 is 0. So now I just want to find f of 0. So f of 0 looks like 2. Looks like they're going up by 2 units there. So f of g of negative 1 is 2. All right. And then the last one on this page, so g of f inverse of negative 4. Okay. So what does this part mean? F inverse of negative 4. So this means negative 4 is an output on my f graph. And then they want to know what's the corresponding input. So negative 4 as an output is right here. What is the corresponding input? That would be right here, positive 4. So f inverse of negative 4 is 4. So now I just need to find g of 4. So 4 is the input. What's the output? That would be 6. So g of f inverse of negative 4 is equal to 6. All right, and then last one on the last page says write an equation for a function that has a domain of negative infinity to 3 and 3 to infinity. So now you are writing a function that has this as a domain. All right. Well, what is this domain saying? This domain is saying every value that you plug in is going to work, but not 3. So how can I come up with an equation where everything works except one number? Well, if you've been watching the video, we just did one like this. Up in part C up here, number 7 part C, we said negative infinity to negative 5, you need negative 5 to infinity. Negative 5 was not included. And what kind of function was this? This was one of our rational functions where we had this fraction. So that's my strategy for this one. I'm going to create a rational function. So f of x equals, and I'm just going to have this be some sort of fraction. Now, how can I make it so that when I plug in 3, I get undefined? Well, there's a couple ways, but probably the easiest way is just to do x minus 3 on the bottom. Because that way when I plug in 3, I get 3 minus 3 is 0, and so this is undefined. And then the top doesn't really matter, because if I get 0 on the bottom, my function's always going to be undefined. So I'll just put like the number 1, or the number 2, or the number 7, or whatever. So this would be an example. There's an infinite number of answers here, but the key is when you plug in 3, you need to get undefined. You need to get 0 on the bottom. All right.